We're on topic 13, and we're going to look at factoring. And basically this is the same kind of thing that we've done before. I've taken some simple examples like a squared plus 2ab plus b squared, factored it like this and into a plus b, and then rewritten it a plus b squared. And you can see the numbers here are exactly the same. We've identified a as 5, b as 3. If we change the sliders on a and b, these numbers should stay the same. Now here I've done the difference of squares. I've said that a squared minus b squared can be factored to a plus b and a minus b. So this number right here is the same as this. If I hadn't factored these correctly, these numbers would not be the same. So it's just a way of verifying and checking, that you've done the problem correctly. So in this particular case, just go up here a bit. Okay. Sorry about that. Now what we have is a is 5, b is 3, difference of cubes. Factored this as a minus b, a squared plus ab plus b squared. These two are equivalent. In other words, this can be factored into that. And similarly, if we go down here, we can see that a cubed plus b cubed can be factored as a plus b, a squared minus the product of these two plus b squared. This number is the same as this, so this and this are equivalent expressions, so I can factor this into this in the same way that I could factor this into that. Okay, so now in this case over here, I've just shown some common errors that you can do. Like often people write a plus b squared, a plus b bracket squared is a squared plus b squared. Well, of course, that's forgetting about the middle term 2ab. So these two numbers are not the same. Similarly, a minus a b cubed does not equal a cubed minus b cubed. And so this number is not the same as that. So it's a way of verifying that you're factoring things correctly. Here what I've done is to show that a plus b cubed is equivalent to a cubed plus 3a squared b plus 3ab squared plus b cubed. So again, we start off with a and b being identified, sliders, and now a plus b cubed is a plus b times a plus b times a plus b. So these two numbers are the same. Now I multiply these two together and I get a squared plus 2ab because I combine the inner and the outer. First times the first gives you this, the last times the last gives you that, and the inner and the outer combine to this. Now what I've done simply is to take now a and multiply it, use the distributive rule by all of this term, which I did over here, and then take plus b and multiply it by all of the second term, which is right here. And you can see, I'm sorry, the bracket here is not shown very clearly, but it is there. This number is the same as that. So now I multiply a times a squared, I get a cubed. A times 2ab, I get 2a squared b. A times plus b squared, I get ab squared. And I multiply this times this, I get a squared b plus b times 2ab gives you 2ab squared plus b times b squared gives you b cubed. Normally, we write the letters here in alphabetical order, so we don't usually write b first and then a. We write a and then b. If there are two terms, write the a term first. Now, let's see what we can combine. The 2a squared and the a squared b combine to give 3a squared b. and the AB squared and the 2AB squared combine to give the 3AB squared. So this term and this term combine, and then this term and this term combine, and that's how we get these terms here. Notice that the value doesn't change. So factoring difference of cubes, here if I take this here, I can rewrite 27 as 3 cubed, and the a to the 6 I can write as a squared times cubed here. So the 2 times 3 is the power rule. Instead of 125 I can write 5 cubed, and now the b is 3 times 3 is b to the 9th. So these two expressions are identical. And now I can factor this as 3a squared minus 5b cubed. I take the first term and I square it. I get 9a to the 4th. I take the last term and I square it, and I get plus 25b to the 6th. And this one always becomes positive. If it's negative here, it becomes positive here, the middle term. If it's positive here, it becomes negative here. And I just multiply 3a squared times 5b cubed. I get 15a squared b cubed. So you can see that I've done this all right because the number doesn't change. Again, I verify by moving the slider along for A and B and just making sure that whatever these numbers are, they don't change. The numbers are irrelevant here. It's that they are the same, 203,000 or 2,038,500 in each of these three boxes. Another difference of cubes, slightly different, because right here we have x minus 1 as one term. So this is like a cubed minus 8. So I'm always going to handle the this particular term as a unit, and I'm going to call it, let's say, a minus 1 cubed minus 8. And instead of writing 8, I'm going to write 2 cubes. So I see that it's a difference of 2 cubes. Now I'm going to write a minus 1 here minus the 2. So that's the first term right here. And I bracketed this here as this. Now this first term squared gives me that. Minus 2 times minus 2 gives me plus 4. Sorry, that should be plus 4 here. Plus 4, you can see it right here. Plus 4, it doesn't look very clear. And then the middle term, we change the sign, and it's 2 times a minus 1, which is here. So then it's just a matter of expanding this to a squared minus 2a plus 1. In other words, a minus 1 times a minus 1 will give me a squared minus 2a plus 1. This 2a is that 2a, and the 2a times the minus 1 is minus 2, and then this plus 4 is that plus 4. And now I just group these terms. This is the same as that. The a squared is the a squared. The minus 2a and the plus 2a cancel, and I have 1 plus 4 is 5 minus 2 is plus 3. So this is the same as that, so I know that I have done this correctly. I'm going to factor by grouping. So I've got 50a cubed minus 100a squared minus 10a squared plus 20a. Going to factor out 10a from each one of these terms. Okay, and I have 10a, and then I'm going to, out of these first two terms, I'm going to factor out 5a. So I get a minus 2 because 5a times a gives me 5a squared. 5a times minus 2 gives me minus 10a. And here I have minus a. And now I put a bracket around this because I want to get the same term here and here. And that's an implied 1, so the value doesn't change here. There's an implied 1 here. Now you see what I can do is I can factor out the a minus 2 from both of these terms. So I have 10a, then I factor out the a minus 2 from here and here, and I'm left with 5a minus 1 right here. Notice this doesn't change. I've done how many steps here? I think I've done 1, 2, 3, 4, 5 steps. I've broken the problem down into very small steps. This ensures that if I make an error, I can probably more easily try to diagnose where that error is. Here, we're asked, given the trinomial, 9x squared minus 3x minus 2, and you can see that the coefficient of x squared is a is 9, b is the coefficient of x minus 3, and c is minus 2. b squared minus 4ac works out to be 81. In other words, these are the values according to what these numbers are here. And since this is a 81, which is a perfect square, the trinomial is factorable using integers. So what I've done here is I've said the product of the first and the last term is minus 18. What are the sum of the numbers whose product is minus 18 and whose sum is minus 3? That's this here. And the answer is minus 6 and plus 3. So I put these in over here, minus 6 plus 3, in order to factor by grouping. So I'm going to group these two together and these two together. Now, out of these two terms, I'm going to factor 3a. And I'm left with 3a minus 2, because 3a times 3a is 9a squared. 3a times minus 2 is minus 6a. And here I have an implied 1 outside the bracket. I'm going to factor the 3a minus 2. I probably should have written it first, but I wrote it second. And then I'm left with 3a plus 1. The order of multiplication doesn't matter, so it doesn't matter if I write this first and this second, or vice versa. Notice this number doesn't change. So this factors down to here. Now you could have used the FOIL method. Also, 3a times 3a gives you 9a squared, plus 3a minus 6a gives you minus 3a as the middle term, and plus 1 times minus 2 gives you minus 2. So you could have done it if you knew that the factors here were 3 and 3. They could have also been 9 and 1, but that you would have never been able to get a middle term of minus 2. So you're left only with a possibility of 3 and 3. That's why we factor by grouping. Some people find it easier. If you find it easier using the FOIL method, by all means use that. So that completes Desmos and applications to topic